So next up on stage, we have two short talks, two 50-minute talks before lunch. And the first is Effy. Come on up, Effy. Going to talk about, I actually don't know, all the clouds, apparently. So please welcome Effy to the stage.
Hi, my name is Effy Elden, and today I'm going to be talking to you about my experiments with multi-cloud serverless. And I've had a bit of a debate on Twitter recently. I'm pretty sure it's multi-cloud serverless, not serverless multi-cloud, but feel free to change my mind at lunch. Anyway, before I take you on this adventure, I should probably set the scene. So, who am I? As I mentioned, my name is Effy Elden, and I am a senior infrastructure consultant with ThoughtWorks. I work with cloud infrastructure, DevOps enablement, and a lot of digital duct tape, in my own words. I have a background in systems administration and support, and I love being able to build cool things in the cloud, essentially. Next up, what? So we have the concept of serverless, and I really don't think I should try and define that. We've had some great definitions today already. If you don't know what serverless is and you're still here, I probably can't help you. And then we have the concept of multi-cloud. And there's a few different definitions out there. There's a few different ways that people can use things in a way that is multi-cloud. But for the purposes of my experiment and the work I did for this talk, I was looking for what I considered the most pure approach to multi-cloud. That is, running an app or a service in multiple clouds at the same time in a way that is resilient, redundant, and taking advantage of the features that those clouds have to offer. And so the intersection between those concepts of serverless and multi-cloud is really where this talk is going to sit. Specifically, for anyone who read my talk description, my goal when I started doing this work was to create a static front end and a stateless back end in multiple clouds at once. And so that's what I was working towards. Why? Why was I working towards this? Well, for starters, it was also kind of where I sat in terms of an intersection of interests. I'd done some work with serverless, and I was doing work with serverless for my day job. I'd started to hear more and more about multi-cloud and the potentials that multi-cloud offered, but I hadn't really explored it, and so it seemed like a great opportunity for learning. Secondly, both serverless and multi-cloud are quite new. And when you combine two cool new things together, what you get is quite exciting, at least to me. I was very excited by the idea of doing this. And lastly, it's cool. After today, I can say I've done a talk about serverless multi-cloud. Sorry, multi-cloud serverless. And that, to me at least, is really cool. So this seemed like a great topic to explore with a talk. And so when I submitted this talk and I got accepted, I had to start thinking about how I was actually going to do this. And there was a few ground rules I set. The first was it was going to be experimental. That is, in agile terms, it was a spike. Because I didn't know what I was going to find. I didn't know what the result would be, and I wanted to keep an open mind. Now, as I mentioned, for my day job, I work with infrastructure as code and with cloud infrastructure quite a bit. And I've actually done some talks recently around the topic of doing higher quality and better tested infrastructure as code, using practices such as clean coding techniques and unit testing. But for the purposes of this talk, all that was out the window. And my mantra was really move fast and break things, because I wanted to have something to show. I didn't want to do everything by the book, perfectly set up in a way that was really easy to maintain and read, but not have it done. And to follow on with that process, I decided I was going to be iterative. I would try and build something, get it working, try and expand upon that, build the next level. I was looking for a minimum viable product at each stage. And lastly, from a technical perspective, the one thing I was really sure of is that I was going to use Terraform. Now, for those of you who don't know, Terraform is an open source infrastructure as code tool. It lets you write code that defines resources that you want provisioned and managed in the cloud. And those can be traditional cloud hosting resources like virtual machines in Azure, or they can be things like repositories in GitHub. And so I knew that Terraform was a really good choice. I was very familiar with it. It was designed to work across multiple different environments, and it was really good at wiring things together, at creating something over here, and then wiring it to something created over here. So with all that in mind, I started thinking, what was my minimum viable product? What was my version 1? And for my version 1, I decided I would have a user, who in this case is Peridot from Steven Universe, and she would have a browser. And when she entered my website in her browser, she would get either a static web page hosted in one cloud or a static web page hosted in a different cloud provider. And so that way, it was the very basic that I thought I could potentially call serverless multi-cloud. And so I started doing this work, but I started to have questions almost immediately. And the first one I had was, how do I avoid SPOF? That is, single points of failure. Because in a traditional system where you have multiple backends that you want to balance between, you have the concept of load balancing. You put something in front, and that directs traffic to multiple backend destinations based on uptime and evenly distributing the load. But that would have introduced a single point of failure into this, and it would have defeated the purpose, or one of the purposes, which was to have that redundancy and resilience. And so the solution I came up with was using the concept of DNS round robin. Essentially, when Peridot connected to her browser and entered in my website, her browser would go and get the IP address for the website, and it would actually return multiple IP addresses for multiple cloud destinations. The browser would then pick one, and she would either end up having the static site served from Cloud 1 or Cloud 2. And that was enough to get started. And so I created the world's simplest, shittiest HTML web page. Literally, you couldn't get simpler. And the important thing here is I had a heading, and I had some text. And that text included this part with the cloud provider. And this wasn't the text that was actually going to appear on the site, because I was going to use Terraform templating to inject the name of the cloud provider that was actually serving this file. So I could see if it had come from Cloud A or Cloud B. And so I then created a AWS S3 bucket, because I was quite familiar with AWS. I'd used it the most for various things, and especially for serverless technologies. And I created an object in that bucket using Terraform. And you can see here I've specified that I've got an index.html file, and I'm using Terraform's template file syntax to actually change that cloud provider string to Amazon Web Services. And I got that all up and running quite quickly. I was very familiar with hosting a static site in an S3 bucket in Terraform, which led to my next question of, how do I certificate? Because in this day and age, you pretty much have to have HTTPS. You have to have a secure connection for web traffic. And in fact, the domain I purchased, which was a .app, enforced that completely. So it was not an option to not be secure. But while it's become a lot simpler to get and manage SSL certificates without lengthy processes or costs, a lot of the methods offered by cloud providers for doing this rely on the cloud provider being able to validate you own a domain by essentially hitting it and seeing, is that coming to me? And that just wasn't going to work if I was pointing my website at multiple different clouds, as I soon discovered when I was trying to set it up in a second cloud. Luckily, there was an answer here too, and that was Let's Encrypt. Let's Encrypt is a free certificate authority. Essentially, if you have a domain name and you can prove that you've owned that through various methods, they will give you a certificate that is trusted by browsers out there. And so I was able to use Terraform with Let's Encrypt to get around this issue of SSL certificate management. And it all worked. So for version 1, I had managed to set up in Amazon Web Services a S3 bucket with my file behind CloudFront, which was a content distribution network, using Amazon Certificate Manager to provide the SSL certificate. And I then managed to mirror this configuration in Google Cloud. I had a Google storage with Google load balancing and Google certificate management. And both of those were underpinned by Let's Encrypt using that same certificate. And it worked. So I had a web page. And that web page, when I loaded it, would tell me it was served from Amazon Web Services. Or it would tell me it was served from Google Cloud Platform. And so I could hit that up, and I could see that it was going to one cloud or the other. Which, you know, mission accomplished. But that was the very basic. That was literally my minimum viable product. And it didn't really feel like I'd accomplished what I set out to do, because I wanted something serverless, and that generally entails more about cloud compute, more about, you know, functions as a service. And so I had my version 1 done. For version 2, I decided I would want to add a backend using a cloud function. In fact, I would probably want to add 2 backends. And so that way, when you hit my website, you would get a web page served from one of 2 clouds, and that would then hit an API, which was served from one of 2 clouds. And that was a nice way to show that multi-cloud approach all the way through. Of course, this diagram is a little inaccurate. Often in architecture diagrams, we show the front end talking to the back end, but really it's not the case. Really, it's much more like the browser is going to hit a front end from one of the 2 clouds, download that HTML page, run some JavaScript, and that's then going to hit one of those backends. So that diagram with the front talks to the back isn't really accurate. So I extended my HTML page to add in a script. And that script was essentially going to fetch my API, and it would then add some text to my page to show me where that API had been served from. And next, I looked at implementing that API. And again, I started with Amazon Web Services, as it was where I was most comfortable. I'd worked with AWS Lambda and API Gateway a fair bit. And I built the world's simplest Lambda function, which essentially would return the name of the cloud. And again, the cloud provider was being substituted in by Terraform as I uploaded it. And that worked really quickly. And then I wanted to add a second cloud. And to spice it up a bit and be a bit more diverse, I decided to use Microsoft Azure, which led to the question of how do I make Azure work? Because I'd never used Azure before, and there was lots of concepts in there that were very unfamiliar to me. And I think part of the problem was I was trying to do everything via Terraform, which meant I wasn't using some of the nice wizards or the nice graphical interfaces. And I'd found this article, which was deploying Azure functions using Terraform. But this guide basically said I had to build a package, create a resource group, create a storage account, specify a service plan, create a storage container in that storage account, then put a storage blob on the package in the storage account, create a shared access signature for the blob, create a function app telling it to use the code from the blob with the shared access signature, create a custom hostname binding, and then give the custom hostname binding a SSL certificate. And that was a lot. These were a lot of new concepts, a lot of new terminology, and I ran into special difficulties with that last step, in that Terraform couldn't actually do that. It didn't support that functionality yet, and I had to manually do that in the end to work around it. And I got frustrated at this initially, but once I understood how it all worked, and it was all working, I looked back and I realized this wasn't actually any more complicated than what I'd just done in Amazon Web Services with Lambda and API Gateway. It was about the same amounts of Terraform, it was about the same amount of resources. It was purely that I was more familiar with one than the other. And that's what I found really interesting, because if I'd had a traditional web server and I'd been hosting that in Azure on a VM, in an EC2 instance on Amazon, that would have been a pretty similar experience for me. My knowledge of Nginx, my knowledge of operating systems would have been universal. But instead, because I was working with serverless, each cloud had this completely different set of abstractions and of concepts that I had to learn. And so all the skills I'd learned from working with AWS quite a bit didn't help me at all when dealing with all these new concepts. So as I said, it was a bit complicated. Part of that was just the differences between different clouds, but part of it was also how much there was to do. And Terraform actually has a feature where you can output a graph of all the different bits, all the different resources it's created and how they link together. And I actually used that to create a graph thinking, this is great, I can show everyone exactly what I've built. But what I got was this. Anyway, I managed to get there. So with my version 2, I had an AWS Lambda function serving as my API, and I had a function app from Azure serving as my API. And when you went to my web page, you could see where the front end was served from and where the back end was served from. And in the least impressive example, it would look like this, where both were served from the same place. There's actually a bit of a bias. If you do go to the website today, you're much more likely to see Amazon Web Services than the other 2 clouds. That's because Amazon, by default, put things across multiple availability zones. So I end up with more IP addresses, which means that if your browser is picking one, it's much more likely to bias Amazon currently. And that was just a flaw in how I did things. And that was as far as I got, because as I said, this was a spike. I didn't want to put too much time into it, and frankly, I ran out of time when preparing this talk. But version 3 onwards would probably look like this, adding in more copies of that front end hosted across more clouds, and more copies of that back end hosted on multiple clouds, and much more complexity as we grow. So I did it. I managed to do what I set out to do in my experiment. But there was lots of complexity. And it was lots of complexity I was unfamiliar with, despite having worked a lot in networking, systems administration, hosting, and similar, because of how vendor-specific it was and cloud-specific it was. But we can use all the clouds. And we should really look at when it's appropriate to do so, when it's appropriate to spread our applications, our services, our workloads across multiple cloud providers, because I believe it's a good way to ensure you have portability built in from the start. It's a good way to ensure that your website is up if half the internet is down, which we see occasionally. There's been massive outages caused by AWS incidents that took down half the internet. And being able to stay up during those periods is really going to give you an edge on your competitors. That said, what I did, while it felt complex, it was still quite simple. If I tried to add in a database or any kind of object storage, and then have that synchronized or accessed across multiple clouds, that would have been a whole new world of complexity. And I'd have had to look into more complicated patterns and frameworks. But yeah, thank you.